Welcome to the solutions to the Regents Physics Modern Physics problem set, problems numbers 1 through 7. Let's go ahead and get started with number 1. Will high-frequency light eject a greater number of electrons from a photosensitive surface than low-frequency light, assuming both frequencies are above the threshold frequency? What they're really asking you is, will the high-frequency light provide greater photocurrent? So let's go back to the photoelectric lessons here. What is the factor, what is the variable that controls the rate of emission, the photocurrent of photoelectrons? Well, the answer is no, because the photocurrent is affected by the intensity, the brightness of the light, and not the frequency. So the frequency controls the energy, the brightness controls the rate of emission, called photocurrent. Number 2. Potassium in a photocell emits photoelectrons when struck by blue light. Tungsten emits them only when struck by ultraviolet light. Which metal has a higher threshold frequency? In other words, which one has a higher FO value? And which metal has a higher work function? Well, the one with the higher threshold frequency is going to be the one where the higher frequency is required to emit them. And looking at your reference table on electromagnetic spectrum, you see that ultraviolet light is higher in frequency than blue light. So, the frequency for ultraviolet is greater than the frequency for blue. So tungsten, because its threshold frequency is greater in ultraviolet than in blue. Since phi, the work function, is calculated by h times the threshold frequency, the answer for B is also tungsten. Because it has a higher threshold frequency, it also will have a higher work function. Number 3. The stopping potential of a certain metal is 5 volts. What's the maximum kinetic energy of the photoelectrons in electron volts and in joules? Well, remember from the photoelectric lessons, the way they used the apparatus to measure maximum kinetic energy was that the stopping potential times the charge of an electron is the electric potential energy. It's the electric work done to stop the electrons from hitting the metal, which is equal to the kinetic energy they attain, the kinetic energy they had leaving the metal. Okay? So, for electron volts, you take your voltage, stopping voltage, which is 5 volts in this case, and you simply multiply by 1 elementary charge. Notice, obviously 5 times 1 is 5, and your units are little e times v, which is electron volts. We discussed this earlier in electrostatics, that this is an alternate form of energy used when dealing with small numbers of elementary charges. For B, you simply want if you want the answer in joules, you take the same voltage and multiply by the charge of the electron in coulombs. So 5 times 1.6 times 10 to the negative 19, this would give you 8 times 10 to the negative 19 joules. Number 4. What potential difference is needed to stop electrons having a maximum kinetic energy of 4.8 times 10 to the negative 19 joules? Nice tie into our previous question. They want V. They told you it was electrons, so you know the Q value, and they gave you the energy in joules. So, just as we just talked about, the maximum kinetic energy is Q times V. They gave you the maximum kinetic energy is 4.8 times 10 to the negative 19. You know the Q value is 1.6 times 10 to the negative 19. So 4.8 divided by 1.6 would be 3 volts. Number 5. The threshold frequency of sodium is 4.4 times 10 to the 14th hertz. How much work must be done to bring an electron to the surface of sodium? What you had to recognize is what they're asking you here is for the work function. That's the amount of energy required to bring an electron to the surface of the metal. So phi equals HFO. Here we'll use the Joule second form of Planck's constant, which you should use unless you're told otherwise, or unless they give you an energy that's in electron volts. So 6.63 times 10 to the negative 34 times 4.4 times 10 to the 14 gives you a work function of 2.9 times 10 to the negative 19 joules. Number 6. If light of frequency 1 times 10 to the 15th hertz falls on sodium, that means it's incident on sodium in the previous problem, what is the maximum kinetic energy of the photoelectrons? Well, first thing you want to check is the incident frequency greater than the threshold frequency. You can see that 1 times 10 to the 15th is greater than 4.4 times 10 to the 14th, so we can proceed here. Ke max equals H times the quantity F minus FO. This derivation was discussed in your video lesson for maximum kinetic energy. So subbing in, again, we've got our Joule second form here. There's your incident frequency. There's your threshold frequency. Do the math, and you should have 3.7 times 10 to the negative 19 joules of maximum kinetic energy. Lastly, number 7. Barium has a work function of 2.48 electron volts. What's the longest wavelength of light that will cause electrons to be emitted from barium? Nice little twist to the question here. Instead of asking you for frequency, they're asking you for wavelength. There's a couple ways to tackle this. You can go ahead and solve for the frequency. Phi equals HFO. So 2.48 equals 4.14 times 10 to the negative 15. Notice you're using the electron volt second form of Planck's constant here times the threshold frequency. The threshold frequency is 5.99 times 10 to the 14th hertz. You now use the fact that these travel the speed of light, so 3 times, and use the wave equation. 3 times 10 to the 8th equals your threshold frequency times the wavelength. You solve for your wavelength, 5.01 times 10 to the negative 7 meters. This wavelength could also be called the threshold wavelength, since this is the threshold frequency. All right, that'll do it for our problems on numbers 1 through 7. More to come with practice on the photoelectric effect when we do problem number 8 in class together tomorrow.